students, welcome to ePhysics. Students, in this video we will be discussing about spherical mirrors. Students, before moving in, we will try to learn the different terms related to the spherical mirrors which will help us to understand the topic very nicely. Now before starting, let us try to find the answer how the spherical mirrors are formed. Now students, let us consider we have a sphere, okay? We have a sphere and we cut a part of it, okay? Now let us consider we have cut this curved structure from this sphere, and let us consider we are having the two structures, okay, two curved structures from it. Now students, in the first figure, let us consider we are polishing the outer part of it, okay, we are polishing the outer part of it. And in the second figure, let us consider we are polishing the inner part of the curvature, okay, this curved part we are polishing the inner part of it. This is the polished surface, okay, the outer part is the polished surface, and here in this case the inner part is the polished surface, okay. And in this, the inner part is the reflecting surface, and in this case the outer part is the reflecting surface. If students, the inner part is the reflecting surface, then these type of mirrors are known as concave mirrors. We call it as concave mirrors. And if the inner part of the surface is polished, then we call it as convex mirrors. If the inner part is polished, if the outer part is polished, we call it as concave mirror. If the inner part is polished, we call it as convex mirrors, okay. Here the inner part is the reflecting surface, here the outer part is the reflecting surface. Students, the concave mirrors are also known as converging mirrors. Why do we call it as converging mirrors? We will learn it later on, but let's understand the things or make it a fact and learn the things before we move to that topic, that the concave mirrors are called the converging mirrors and the convex mirrors are called the diverging mirrors. Diverging mirrors, okay. Now these are the two type of spherical mirrors about which we are supposed to study the things, okay. These are the only two surfaces that can be created, the spherical surfaces that can be created for our study part, okay. Now let's move to the terms related to the spherical mirrors. Now students, suppose we are taking a concave mirror, okay. Let us consider we are taking a concave mirror, okay. Now students, we know about the diameter because this was a part of a sphere, so definitely this will having a diameter. Let us consider this is the line which we have created, is the line along the diameter of that sphere. Now students, if we incident any light ray parallel to this, what will happen? Now if we incident any ray parallel to this line, okay, this line, the rays get collected through a point. Now let us consider we are taking the other light ray, and again the same thing happens, the light rays moves or passes through one point, and this point where the light rays after reflecting is passing through is known as the focus of the spherical mirror, okay, focus, we call it as focus. Now the next thing students, when we know the laws of reflection, okay, we know the laws of reflection, the incident ray, the reflected ray, and there was the one more line we have used to create, and that line is known as the normal to the surface. Normal is created from the point where the light ray is incidenting on the surface. So you might have studied that in mathematics, that if we have a tangent on a circle, from the point of contact, if we draw a normal to it, if it passes through the center of the circle, okay. Now similarly, if we draw normal to this surface, okay, from this spherical surface, it will pass through a point, and this point, again normal to the surface, it will pass through a point, and this point is known as the center of curvature. Center of curvature. Clear? This is the point center, and this is the focus point. We denoted by F and we denoted by C. Clear? And students, if we join these two lines and draw a straight line, I will draw this a similar figure. Now students, if we join these two lines, okay, the focus, these 2 points, focus and the center of curvature, and we draw a straight line through it, we get a line which is known as the principal axis. We call it as principal axis. And the point where the principal axis is meeting the surface of the mirror, we call it as pole. The length between the pole and the focus is known as the focal length, and the length between the pole and the center of curvature is called the radius of curvature. Okay students, and one more fact about it is, when we do the calculations, we get that radius of curvature is always 2 times the focal length of the spherical mirror. Okay, in this case we have considered the concave mirror, but these terms are similar in the convex mirror as well. So now you will ask a question, or the question might raise in your mind, that how can we say that r is equals to, that is the radius of curvature is equals to twice the focal length. Okay, we have a calculation related, we have a derivation related to this, the mirror formula and the lens formula, but from class 10th point of view we don't need to understand those derivations, but I will discuss it in the next videos. But before, in this video we will only discuss about the spherical mirrors and the formulas related to it. But before that, moving to deep to the topic, we will try to learn about the terms. So here we have learned about the different terms related to the spherical mirrors. I hope you get it, and in the next video we will be discussing about the formulas and the light rays passing through the spherical mirrors, how does it reflect and how does it behave, where the image will be created. We will be discussing about the rules of incidenting the light and the reflection of the light through any spherical mirrors, whether it is a concave mirror or a convex mirror. That will be discussed later on in the next video. I hope you understood the video very nicely. Thank you very much for watching the video.